So when you get to this point, 0 equals 50 is your A, your first factor is t minus 3, and your second factor is t minus 4. Now you can solve this relationship because you know that the zero product property says that either the first product is 0 or the second product factor is 0. If the first factor is 0, if t minus 3 is equal to 0, that just means t is equal to 3. And if t minus 4 is equal to 0, that just means t is equal to 4. As you can see, t is the ticket price for these tickets for the revenue of a theater group and the cost of a theater group. So these are both okay answers because they are both positive answers. So therefore, the break-even point is when the tickets are either $3 or $4. So if they charge $3, the company will break even, and if they charge $4, the company will also break even. I suggest that you try to maybe even graph this thing so you can see what's going on, and so you can actually determine when the company will actually lose money and when the company will gain money. But when you go to graph that, you should end up with something that looks like this, where the first x-intercept is 3, the second x-intercept is 4, and this parabola obviously opens down, so it looks something like this. They will gain money in between 3 and 4, and actually you'll hit a maximum at 3.5 when you charge $3.5. So sometimes you'll end up with something like this, but other times you'll actually end up with a negative answer for one of your t's. Therefore, the negative answer would be inadmissible. But in this case, neither of these answers are inadmissible. That is when the profit will be 0. Either the ticket price is $3 or the ticket price is $4. So this section, once again, is to come up with the point of intersection or points of intersection of a linear quadratic system. Again, a quadratic system could have a linear quadratic system could have 1 point of intersection, 2 points of intersection, or no points of intersection. You also have to remember that the points of intersection of a line and a parabola can be found by graphing, which is something we're not going to do, or by using the substitution method, and that's what we've used over here mathematically. But in essence, if you did graph the parabola and the line at the same time, you would see that this parabola and line would intersect at this point and this point, and same over here. However, also sometimes one of the solutions is not admissible, and that's when we're dealing with a real-life situation. So that's pretty much it for linear quadratic systems. And if you complete your homework there, you'll notice that you're always going to make one function equal the other function so that you know exactly where they intersect.